Okay, guys, the last lesson I had you look through mentioned something called the axe rule, and it also mentioned something called quadrantal angles. So this is a super big concept that we use throughout the rest of this class. And it says here in the instructions, find the exact value of each expression without using a calculator. Okay, there's going to be one little exception at this current spot we are together. If an angle is quadrantal, I'll let you use your calculator. But I also gave you guys a little chart of values in my last lesson, so you could use that if you wanted also. But you'll see that there are, well, problem 67 to 86. This is page 99 in the trig book. Some of these are negative angles too. So remember, negative angles are people too. They just rotate clockwise instead of counterclockwise. But you'll notice some of these angles are quadrantal. If they are quadrantal, you may use a calculator this time. So here we go. Here's the answer key for those ones too. And what I want you to kind of notice is there's a lot of repetition in the type of answers you get. There is. When you start messing with trig, you'll start going, dang, I get this answer all the time. Sometimes it's positive, sometimes it's negative. But the thing is, there is tons of patterns and tons of repetition in trigonometry. My job is to help you get there, but your job is to finally embrace it and see it. So, you're going to see a lot of repetition today. And it says here, the questions are on page 99, 67 to 86. It says, draw the reference triangle for each question if the draw the reference triangle for each question, period. If the angle is quadrantal, you may use a calculator. So I want to see you guys try to draw a reference triangle for everything. But if it turns out being quadrantal, you cannot label a reference triangle for that. But you'll notice I've underlined this, label your reference triangles for full credit. If you don't, down the road it's going to bite you in the butt. You're not going to be a happy kid. Believe me, this is just the tip of the iceberg. So, what kind of questions are we going to answer? Well, we're going to answer these kind of questions. What is the sine of 45 degrees? And I go, oh, I know how to find the sine of 45 degrees. Oh, wait a minute, we're not going to give you anything in degrees anymore. We want to make sure that you are not uncomfortable if we use radian measurement. And I go, oh, sine of pi fourths. Okay, well, that's different. I don't know what pi fourths is. I've only converted these for one day. Well, guess what? If you don't recognize what it is, you can always definitely convert. And if you convert, you go, oh, that is a 45-degree angle. What I'm trying to get at is the book is going to give everything to you in radians. Everything. Look, everything's radians. So if your first thing is, I'm going to convert it into degrees so I understand it better, then do that. That's okay. I don't care. But the answer for this thing is going to be rad 2 over 2. Now, the reason I know that is I have this burned into my brain, but you don't have to memorize things. The beauty of trigonometry is you can always draw a useful picture to help you do stuff. So instead I'd go, okay, a pi over 4 angle, that puts me right there. So this guy right here, that guy's pi over 4. That gives me this right triangle. And I know that's a 45, so I go opposite is a 1, opposite, that is a 1, this is a rad 2. Because remember, we're going to be using our special triangle stuff. So for 45/45s, we use 1, 1, rad 2. For 30, 60, 90s, we use 1, rad 3, and 2. So guess what? We're going to find a lot of multiples of 45, 30, and 60. We are. And then I go, hey, that's opposite, opposite over hypotenuse. So that would be 1 over rad 2. And then I'd say, hey, I got to get the rad 2 out of the bottom. And then lo and behold, there's the answer I told you it was in the beginning. But here's the thing. Sometimes sine is negative. Sometimes cosine's negative. Sometimes secant is negative. How do we get these answers that are negative for some of these functions? Well, here we go. What I'm about to show you is called drawing reference triangles to evaluate the trig functions, not so you, because see, if I had punched sine of 45 in on my calculator, I'd get an ugly decimal. Well, that's because it's based on this ugly number. But the thing is, they want exact values. Exact value. Whenever they say exact value, it means you better not give me a decimal. The only time it's considered an exact value if it turns out to be a whole number, a regular fraction, or a radical. So like this answer here is a whole number. This answer here is a fraction. These are radicals. Not one spot on this answer key do you see a decimal, and you won't. Any decimal answers are automatically wrong and worth 0 credit to me. I need you to be able to calculate exact value answers for me. So you'll notice like number 86 here, that's a negative answer. Number 78, that's a negative answer. Here's what happens. I'm going to show you how to get these type of answers. Whoops, I don't want that. I don't know what that was. Anyway, here we go. What if they asked me for the cosine of a 3 pi fourths angle? Now, 3 pi fourths is radian, and if your brain is if your brain is unhappy about that, you could say, I'm going to change 3 pi fourths into degrees. You could. Eventually, what I'm hoping is that you will just find that, oh, this is going to be the same thing as a cosine of 135 degree angle. I'm hoping that eventually you just embrace it and become damaged like me and you say, oh, 3 pi fourths, I get it. Come on, straighten up line. One more try. There we go. See, I can draw a 135 degree angle. I can, look. There's 0 degrees, 90 degrees, there's 135. All right, I kind of overshot it a little bit. That looks more like a 170 degree angle, but you get my idea. I'm in quadrant 2. When I draw this angle, 135 degree angle, I'm in quadrant 2. It has a terminal side. That is the side at which it stops. Oh my gosh. Then, and guess what? This is my 3 pi fourths angle. Same as a 135. But you know what? I can't draw a right triangle that has a 135 degree angle in it. So what do I do about something like that? What do I do? Well, guess what? We draw something called a reference triangle. This guy right here is called the terminal side. We've talked about this, terminal side. And wherever the terminal side is, I stop and I connect that to the x-axis. I connect it to the x-axis, which then gives me a right triangle. Now, I know that the angle I'm looking for, and I'm going to get rid of this for a second. I know the angle I'm looking for is this one. That's the angle they want me to find. What is the answer here? Well, what we do is we draw something called a reference angle. And a reference angle is always some angle, I don't know, I'm going to call it theta, that lives inside my reference triangle. So how big would that angle have to be? How big would this have to be? Well, I know that this big angle is 135, so this little tiny one had better be 45, because I know that from here to here, that's 180 degrees. I go, what the heck? How fresh is that? I'm going to get rid of that big arc. So guess what? If that's a 45 degree angle, opposite is a 1. Over here's a 1, and here's a rad 2. But guess what? One of these numbers is on the negative side of the x, so I have to put a negative on him. This guy is going to stay positive because he's on the positive side of the y-axis, and the hypotenuse is always positive. Now, you do not have to write in the signs of positive things, but I want to make sure you know why I'm going to get a negative answer here. My answer is going to be negative rad 2 over 2. The original question said, the original question said cosine of 3 pi fourths, but I converted it and then I solved it. Because remember, how am I getting my answer? I'm doing adjacent over hypotenuse. Adjacent over hypotenuse, but then I get the rad out of the bottom, and I end up, oh, bam, there's my answer. My respuesta. Let's continue to play. Let's continue to play. What I'm showing you how to do basically is called drawing a reference triangle. So let's pick on tangent. We haven't played with tangent yet. And let's do tangent of 7 pi sixths. And you go, I don't know what 7 pi sixths is. Well, that's why we did the first video, so you'd know how to convert it. But eventually what you will do is exactly what I'm doing in my head this whole time, which is calculating its 2/10. I'm just showing you how to do it to remind you, you know how to convert, but eventually you'll become brain damaged like I am, in the sense that when I look at 7 pi 6, I know it's 2/10. I don't even convert using a formula anymore. I just go there. So what happens? If I draw a 7 pi 6 angle, that would put me right there. This is called my terminal side of that angle, right? This is my terminal side. If I take my terminal side and I connect it to the x-axis, I will create a right triangle. It will have what's called a reference angle inside of it. And that reference angle will be, in this case, 30 degrees big. It is 30 degrees big because I know from here to here is 180, plus 30 more would give me 210. So let's label this. Opposite the 30 is 1. That means over here would be a, that means over here would be a 60 degree angle. So that would be a rad 3 over here. That would make this a 2. But since this angle is in quadrant 3, that means this guy's negative because he's on the negative side of the y-axis. And this guy's negative because he's on the negative side of the x-axis. That's called drawing a reference triangle. You take the terminal side, you connect it to the x-axis, then you get what's called a reference angle. Once you have a reference angle, you can label the sides of your triangle, and then you could say, what did they want? The tangent? Okay, I can do that. The tangent of this angle that I just drew, this reference angle, is the same as going to be the tangent of that. So I do opposite over adjacent. And then I'd say, wait a minute, these negatives cancel. I can get the rad 3 out of the bottom. Surely I could. So my answer that I want is rad 3 over 3. And it's positive. Now, just for kicks, if your calculator is in degree mode, and most people think in degrees, so I'm no different. I have my calculator currently set in degree mode. If I punch in the tangent of 210, the tangent of 210 degrees, I will get, for the tangent of 210 degrees, I will get this decimal, 0.57735. It just keeps going, keeps going. But you know what that number is? It's the exact same thing as if I punch in on my calculator the square root of 3 divided by 3. If I punch in the square root of 3 divided by 3 on my calculator, I will also get 0.57735, la 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 la. Just remember, when you punch it in on your calculator, you got to close that parenthesis. What I'm trying to say is, this reference triangle stuff allows you to come up with the exact value. If you go to your calculator and try to do math frac or some magic like that, It will never give you back the radical. The only thing that knows how to convert a decimal that's irrational back into a radical is your brain. That is the only way to do it. Let's play just a little bit more. Okay, let's do a quick one. What if they said, let's find the secant of 3 pi halves? You know what? Let's spice it up. Let's make it negative 3 pi halves. And then I go, wait a minute, that's negative. That guy, and once again, I can convert it. I totally could. And I could, oh, my dog is in the room, by the way. Bam, bam. I could convert it, and I would get, shh, dog, please, negative 270. So I'm going to do this one fast because I might have to jump up and let my dog out. If I did a negative 270 degree angle, which is the same as a negative 3 pi halves, guess what? Ding, ding, ding. This is when we have something that is quadrantal. I can punch this in on my calculator. I totally can. But my brain doesn't think in terms of... Oh my gosh, that's too funny. Let's see, I'll walk with the iPad and try and let him out. My brain doesn't think in terms of secant. My brain thinks in terms of cosine. So if I wanted to, I could find the cosine of this answer and take its reciprocal. So how do I do that on my calculator? Well, if you're in degree mode, you punch it in degree mode. If you're in radian mode, you do it in radian. So I would do this. I would do cosine of negative 270 degrees, and I would grab my calc and say cosine negative 270, and I would get the answer 0. This would be the answer 0. What's the reciprocal of that? Well, that would be 1 over 0. Well, wait a minute. You can't divide by 0, so the answer here would be undefined. Now, we have that in that chart. I showed you that in a couple videos back, that chart. You can't divide by 0. So 1 over cosine, that would be the same thing as saying secant of that. But your calculator would give you an error message if you tried to punch that in all at once. So guess what? When it comes to quadrantal stuff, when it's quadrantal, I still want to see your picture. You better draw your reference triangles, but this one, of course, does not result in a reference triangle. It ends up in a dead end right here. But guess what? You can punch those in on the calc for now. All right, let's do just one more. What the heck? Let's do one more. Let's do cosecant of negative 7 pi fourths. I go, okay, 7 pi fourths. I don't know what that is. And you could then convert the thing that you are looking at into a degree mode and say, oh, I know what negative 315 looks like. I would start, of course, on the positive side of the x-axis, and I would rotate this way. I would go negative 315 degrees, which would give me a terminal side. Then I would take the terminal side, I would connect it to the x-axis, I would form a right triangle, and I would mark this angle and say, that's my reference angle. And that reference angle is how big? It is 45 degrees big. So I'd go, oh, 1, 1, rad 2. And I'm looking for cosecant. Cosecant, yeah, I don't think that way, but I do think in terms of sine. So I would say, you know what? If you ask me for the sine of that angle, I would say opposite over hypotenuse. But then I'd say, I have to get the rad out of the bottom. And I'd say, whoa, put the brakes on. You don't have to get the rad out of the bottom. Your answer is not this. Your answer is the reciprocal of that. So just flip it over and call it a day, buddy, because you are done. Now, the one thing I want to make sure that you always understand, there are a couple truths about every single reference triangle in the world. Okay, every single reference triangle, there are a couple things that are valid always. Number one, when you draw a reference triangle, it's either going to end up being on one of the axes, which means it's quadrantal. You can't draw a reference triangle. Or it's going to end up in one of the four quadrants. And no matter where it stops, it will have a terminal side. Reference triangles all have terminal sides. And that terminal side can be connected to the x-axis. I am running out of room. Why don't I just scroll down to the x-axis? So if I draw anything, I have a terminal side, I could connect it to the x-axis. Guess what? I got a reference triangle. I could draw terminal side, okay, oh, that was horrible. Terminal side, connect to the x-axis. Boom, I got a reference triangle. Hang on. I'm trying to get a different color pen. I could draw an angle with a terminal side connected to the x-axis. I've got myself a reference triangle, okay? I can end up in any of these quadrants. I could end up in quadrant 1. I could end up in quadrant 2. I could end up in quadrant 3 or 4, but whatever happens, I'm going to end up with a right triangle if I connect it to the x-axis, which would then make this guy here my reference angle for quadrant 1. That would make this guy here my reference angle if I was in quadrant 2. That would make this guy here my reference angle if I was in quadrant 3, etc., etc. Okay, so here's the thing. Reference triangles all have terminal sides. That terminal side can be connected to the x-axis. Don't ever connect to the y-axis. You will get the wrong answer every time. So here's how I remember it. For reference triangles, terminal side of angle always, and I love when you get to use the word always in math, always connects to the x. Connects. See how I spelled the word connects? The way it should be spelled. Terminal side of an angle always connects to the x. Okay? And then, here's the other universal truth forever and ever with this concept. Okay. The angle formed between the x-axis and the terminal side is always, love when I get to say that, the reference angle. Okay? Or some people like to think of it this one. The angle at the origin. Okay, so look at all my reference triangles I've drawn for these examples. So here we go. See how that one, there's the terminal side, and then I connect to the x, and then the one that's coming out of the origin is my reference angle. This guy was quadrantal, so he doesn't count. Quadrantals are a different bag. Take a look at this one. I drew an angle. It had a terminal side. I connected to the x-axis. There's my angle theta that I used, my reference angle. Juts out from the origin. Here we go. I drew a 135-degree angle. I had a terminal side. I connect to the x. There's my reference angle, the one that's formed between the terminal side and the x-axis, etc. Look, this was my first one. I just drew a regular old triangle, but it's still between the terminal side and the x-axis, and it's the one that comes out from the origin. Not this one. No, not that one. This one, the one from the origin. It originates from the origin. Oh my gosh, all kinds of fresh ways to say that. So guys, this is one skill that is crucial for the rest of our trimester together here. So here we go again. There's the ones I want you to practice. You draw a reference angle for every single one. Every single one. Even if it's coterminal, whatever. I want to make sure you got it. And then I do have some follow-up practice I'm going to give you in the Zoom room. So here we go. There's the answer key for it. I kind of marked up the answer key. Now I kind of feel bad about that, so I'm going to go back and erase all this stuff. Okay. There you go. All right. Catch you later. That's the end.